Jai Sri Krishna. Let's start discussion on very important topic, that is a quantum leap realization fraud detection with quantum computing. And this topic is very important, guys. So how we will do fraud detection in bank, financial institutions, or the insurance companies in future with using the quantum computing and AI ML techniques. And guys, if you are interested to learn more about the quantum computing or new AI ML techniques, how it will work, so please like and subscribe my channel. So I am creating videos on both the hot topic in the market. One is a quantum computing and the AI and artificial intelligence and machine learning. So let's start a discussion on these topics of fraud detection with the quantum computing and how the future will look like of it. So let's move on the next slide. So the evolving threat landscape in the financial crime, and what is the financial crime and what is the problem in the financial crime. So the financial fraud is a global issue and costing the billions dollar annually, and the criminals will find new techniques or new way to do the criminal activities in the anti-money laundering, counter-terrorist financing, or to do the frauds, and that with the traditional techniques or the old computer system, the classical computer system, is difficult to track such things. The fraudulent schemes are becoming more sophisticated, often leverage AI to increase their effectiveness with the speed, and that will increase. So it is, the with the classical computer, it's very complex and very, it increase the fails positive rates, and it's not easy to. There is also the huge volume of data. So that's why we are moving from classical computer to the quantum computing, and that's the importance of quantum computing. So the classical, computing limitation is the data volume. So it's the data volume is increased day by day, and the classical computing get the result will take huge amount of time, and that's not sufficient for us. So we need the computer which work very fast and very fast. So the traditional systems struggle to process the massive high velocity data, generate the real time transactions, or to do the real time transaction monitoring, or the name screening or payment screening. So the classical system are not sufficient for that, and the complexity, the identify the stubble complex fraud pattern that are rare occurrences and weak in statistical signals, is a computationally intensive and lead to high fails positive rate. So the complexity is very high, and the fails positive rates of such financial crime is very high for the classical computing. So that's why the banks or the financial institutions are moving from the quantum computing and AI ML techniques with the quantum computing. So quantum AI, the concept will come in the futures, and speed. The current system cannot be the current system can be too slow to detect the block new rapidly evolving fraud attacks in the real time. So new techniques are evolving, and the current system are too slow to identify such things. The classical system are too slow to identify such things. So let's move on the next slide. That is the introduction to the quantum computing. So guys, before going to the quantum computing, you should know what is the quantum computing, how it works. And if you are working any field like a quality analyst, business analyst, quant analyst, or developer, tester, so what thing you need to move, what thing you need to understand, it is a classical computing technique. So just move on the quantum computing. So I think there is a huge revolution, huge technology transformation is come in the futures, and more jobs come into the field of hybrid computing, classical computing and the quantum computing. So you should know this knowledge. So, okay, what is a quantum computing? A new type of computing that use a principle of quantum mechanism to perform the calculations. It is the new way of doing computing. It is a new things that use a quantum mechanism for the perform the quantum, the calculation by using the computer system. So the key concept. So it's the classical computer work on the binary things 0 and 1, but the quantum computing will work on the qubits. Unlike the classical byte 0 and 1, the qubits can exist the superposition for both states simultaneously, and that will the simultaneous or the parallel activity will happen. So that's increase the performance of the the system or the speed of the system and the superposition. This allow quantum computer to explore all possible solutions at once and dramatically speeding up certain types of problem and increase the speed and easily availability of the speed and system will very work fastly and with the huge amount of data, and we know the data volume are increasing day by day, and for working on that data the classical computers are not sufficient, so we need a quantum computing that work very fast. And the entanglement qubit can be linked so that the state of intense instantly affect the state of another no matter the distance. The enable highly incorporated data analysis, and it will increase the data analysis speed. The data analysis, quant analysis, everyone work on the quant and they need to understand the quantum computing technique. So let's move on the next slide. So the quantum advantage in a fraud detection. After we are going to implement the quantum techniques in the fraud detection, what the benefits we are going to take from the quantum technology. So quantum computing offer a step change improving in the fraud detection by leveraging the unique capabilities, and it will do the real-time analysis or it will generate the real-time fraud detection and the minimum human interaction of that systems, and immediately system will do the debit freeze of such account. So enhance the pattern recognition, quantum machine learning QML. So the new techniques will come, that's quantum machine learning algorithm can analyze vast data sets to identify the hidden patterns that classical algorithm might miss. And there is the new techniques, quantum supervised learning, quantum unsupervised learning, quantum deep learning, quantum semi supervised learning, quantum bias, quantum, quantum related technologies. We work on the quantum technologies and that will detect the the customers is a fraudulent or non-fraudulent, if the transaction is fraudulent or non-fraudulent, to generate the true positive on the basis of rules or on the basis of AIML logic. The quantum computing will work there and that will enhance the recognitions of pattern or the behavior of the customers. For the real-time analysis, the parallel processing power of quantum computing could allow for near the instantaneous analysis of transaction, enabling the real fraud prevention. So it will do the real time analysis. The quantum computing will do the link analysis, the quantum network analysis, where we can identify the source of fund or the destination of fund. With using the quantum computing, we generate the graphs, heat maps, we generate the pie chart, flow chart. So through the help of the quantum computing, and there is a quantum will involvement, and it will work very fast, and it will help us to reduce the false positive rate. So in the current system, if we are using AML, again the system will generate more the false positive. But if we implement the quantum AML technique, so system will itself generate the huge the true positive rates and reduce the false positive rates by accuracy distinguish between the legitimate and the fraudulent transactions. The system will itself able what are the legitimate, what are the non-fraudulent transaction and the fraudulent transaction. And quantum enhance the system can minimize the number of fails alert, improving the customer experience better and efficient and operation efficiency of that system. So that's the benefits of the quantum computing in the fraud detection. So let's move on the next slide. The key quantum algorithm or the applications that we need to use, that we need to understand as a part of the fraud detection or the financial crime team or the forensic team. So first one is a quantum support vector machine. So quantum support vector machine is one of the new algorithm or the algorithm that can find the stable complex correlations in data to classify the transaction in fraudulent and legitimate with high precision or the accuracy. So that's the one of the thing, quantum supervised learning, quantum semi supervised learning, quantum lasso, quantum reads. These are the techniques are coming in the futures, and we need to understand that technique with AI, ML, machine learning with the quantum analysis and the Grover algorithm. So can be used the unstructured searches, potentially speeding up the process of searching large databases for the specific fraudulent pattern. So that's the quantum technique will use, and the quantum analytic annealing and optimizing technique that can use for a model complex financial network and identify anomalies in a single fraud rings and money laundering techniques. So we will use to identify anomalies or fraudulent transactions in the money laundering and counter terrorist financing. So that's the key application we use in the futures for the quantum sites. So let's discuss on the initially what approach we need to follow before implementing the fully functionality quantum technique. So we will move hybrid quantum classic approach, so where the quantum technique will work and the classical computer will work. So the we need to use the no, we use the 360-degree architecture, not a monolithic architecture. Microservice architecture, we move from monolithic to microservice architecture, and that will very useful for here. So the near term reality, the fully fraudulent, the fully fault uh, tolerant quantum computers are still in the futures. They are not currently happening. The most practical approach is now is hybrid quantum classical models. We need to work and build such models. So how it work? Classical process, pre-processing. Classical system handle the bulk of data processing and filtering, and then the quantum enhance the speed complex and computationally intensive tasks such as feature selection or finding the stubble pattern are obtained and quantum computer. So quantum computer will do classical pre-processing, will do the classical computer, or the quantum enhancement will do the feature selections, finding the stubble in pattern, or do the calculation. So that where we use the quantum techniques and the classical actions. The result from quantum computer feed into the classical system and decision making. So there is hybrid approach, so there is all these things will work. So that's the things we need to do in there. Let's move on the the last slide, that is the challenges and the road ahead of with the quantum and the classical things, or what challenges we need to think. So let's discuss on the technological hurdle. So the qubit limitations, the current quantum computer have limited number of qubits and are prone to error or the decoherence. So there is the issue in the quantum limitations. The current computer are not sufficient for the quantum techniques. They are working on the binary, and the quantum computing are the qubits. So that's the one of the greatest challenge in the upcoming area. And then the scalability cost, scaling up quantum hardware is difficult and expensive. So it's the we will move totally in the new technique. So that's the costing. We need a new infrastructure, we need a new system that support the hybrid model or the quantum systems or the quantum algorithms, quantum AIML algorithm. So that's also human can understand that thing. So that's the one of the cost and the scalability challenge, and the interpersonal and skill gap. So in integrating quantum system with existing financial infrastructure is a major challenges. So we need to move, I already told you. So that there is a huge migration will happen from the classical computer to the quantum computing, and that we need to understand that migration and work on that migration. And the to the skill person who understand the financial knowledge or the financial crime knowledge or the AIML techniques or the Python language or the SQL language or the machine learning or mathematics, physics, statistics, or the quantum computing. So to find such needful person or the skillful person in the area is a very challenging and very complex task. So the technological gap is there, and there is a significant shortage of experts with skill both quantum mechanism and the finance and the AI, which I already told you. So these are one of the important challenge. And the post quantum cryptography, a separate but related challenges in the need to develop a new uh, encryption standard that are resistance to attack from future powerful quantum computers or the quantum techniques. So these are the challenges for the quantum. So let's move on the non last slide, that is a conclusion. So quantum computing is not a replacement for the classical system but a powerful tool to augment them. So think on the classical computers are not replacing. So there is, we merge them and we generate the faster way of doing the computing or faster way of working. And maybe the future is the quantum computing. In the coming year, hybrid quantum classical system will lead the charge in creating the more accurate and efficient and robust fraudulent detection system that will detect the fraudulent activity in the system. So the future will work on the hybrid model, and by innovating in search and the developing now, the financial institution can positive themselves to gain the significant competitive advantage in the next era of cyber security, and it will 360-degree way generating the changes in the advantage and the quantum computing field. So that's the end of the slides. If you like my videos and my efforts, please do like and subscribe my channel, so that motivate me to create and more such videos for you. So thank you so much, guys, once again. Thanks.